Hi, it's Mark Lance again to continue our lessons to prepare you for the GED test. Today we're going to be talking about, or in this lesson we're going to be talking about division of fractions. The last one was multiplication of fractions. And I just want to remind you, if I say something that you're not clear about, that maybe I'll refer to it as something we did in the last class, you could go back and check the previous video and maybe that'll answer your question. The idea, I'm trying to build these sort of sequentially so whatever we do in one lesson kind of stands on top of what we did in the past. If that's not clear to you, go back and look it out and hopefully that'll answer the question. Okay, so we're going to talk about division, and students usually think that dividing a number makes a number smaller. Well, for whole numbers that's true. 12 divided by 4 is 3. The 12 got smaller, turned into a 3. But it's not true for fractions. If you divide a whole number by a fraction, the answer will be larger than the whole number that we started with. So I always use the example of a laundromat. So let's say you're going to do your laundry and you need a bunch of quarters for the machines, and you have $10. So you go up to the person in charge, or the machine, or whatever it is, and you're going to give them $10, and you're trying to figure out how many quarters you're going to get. Well, if you think about it, each and every one of those dollars is going to have 4 quarters in it. And for $10, you're going to want 40 quarters back for your $10. Mathematically, we'd be doing this. We'd be saying, here's $10, and we want to know how many 1/4 are there in that dollar, okay? So the problem would be 10 divided by 1/4, okay? So before we answer, I think you know the answer already. Everybody's usually pretty good on their money. That I'm sure everyone, if you got less than 40 quarters, you'd be pretty mad. But I want to step back and talk about something. So we know that the answer is going to be 40. And so the basic lesson to remember is that dividing by 1/4 is the same as multiplying by this number turned upside down. 4/1. So we change the sign, and when we change the sign from division to multiplication, we're going to flip this fraction upside down. So here I want to step back and talk about something else just for a second, and we'll come back to this. These two numbers, 1/4 and 4/1, obviously don't equal each other. I'm not trying to say that, but they do have an important relationship, and what they're called is a reciprocal. So if you take any number and flip it upside down, you're going to have its reciprocal. It's true for any number. Just flip it upside down. The mathematical definition for a reciprocal is either of two numbers whose product is 1. So if we multiply 1/4 times 4/1, I don't think you'll be surprised. 4 times 1 is 4. 1 times 4 is 4. 4/4 is 1. These two numbers are reciprocals of each other. It doesn't have to have a 1 in it either. Here's 3/4 and 4/3. Well, think about what this means. They're both going to end up being 12. 3 times 4 is 12. And 4 times 3 is 12. 12 divided by 12 is 1. So what I'm trying to say is what we said here before. That dividing by this number, dividing by 1/4, is the same as multiplying by its reciprocal. 4/1 is the reciprocal of 1/4, and now it's hopefully going to start to make some sense. 4 times 10 is 40. 1 times 1 is 1. So when you're trying to figure out how many quarters are there in $10, the way to figure that out is to multiply this $10 by the reciprocal of 1/4. Dividing by 1/4 is the same as multiplying by 4/1. In class, a lot of times I just talk about flipping numbers, and that's true, but I want you to understand that what's behind that. That these two numbers are reciprocals, and what makes two numbers reciprocal is if you multiply them and you get 1. It's going to be very useful not only now, but as we move into algebra. Okay, so let's see here. Let's look at some, here's another example. 8 divided by 1/2 is the same as what? times, so we're going to change it from a division sign to a multiplication sign, and we're going to flip it or change it to its reciprocal. And think about that. If you had $8 and you wanted to turn them all into half dollars, how many half dollars are you expecting to get for $8? Each of those dollars has 2 half dollars in it. So you're expecting 16 half dollars. 1 half goes into 8 16 times. Okay? One other thing I'd like to mention where this is useful, let's say we had a problem, well, let's say 1. 8 divided by 1 half. And a lot of times my students say, oh, I hate fractions. Well, if you don't like dividing by this, we know that it's the same as multiplying times the reciprocal. Okay? 8 divided by 1 half is the same as 8 times 2. 16 half dollars and $8. Okay? All right. Let's look at a couple of problems. 7/8 divided by 1/16. Okay, the very first thing I would do is change it to a multiplication problem. We already know how to do them. 7/8 times 16/1. See what we did? When we changed from a division to multiplication, we flipped this or use a reciprocal, and now we get to do some canceling. So this problem that looked like it was kind of hard before, now we see we can cancel. 8 goes into 8 once. 8 goes into 16. 7 times 2 is 14/1, or 14. Not so bad after all. Okay? How about another one? How about 4/5 divided by 4/9? Okay. 4/5 times 9/4. And now what looked like a kind of a hard fraction problem, now we even get to do some canceling. 4 goes into 4 once, 4 goes into 4 once. So this ends up being 9 times 1 is 9, 5 times 1 is 5, 9/5. Improper fraction, so we'll divide 9 by 5. 5 goes into 9 once, with 4 left over. 4 what? 4/5. Let's just check that with Sister Mary Victor way. 1 times 5 is 5, plus 4 is 9, 9/5. They're the same thing. Okay? This next problem is exactly like the laundromat problem. 12 divided by 1/4. You have $12. You want to know how many quarters you're going to get for that. Okay? Each of these dollars is going to have 4 quarters. I don't think we even need to write this down. If you have $12 and each one of them has 4 quarters, isn't that going to be 48 quarters? 4 times 12 times. It ends up just being what we said. 4 times 12 is 48. Okay? Let's do like what we did with multiplication. And our next candidate here is 6 divided by 2.5. All right, well, let's change this to an improper fraction first. So 6 divided by 2 times 2 is 4, plus 1 is 5, 5/2. These two things say the exact same thing, okay? Now, since we won't have our answer yet, instead of divided by 5/2, it's going to be multiplied by 2/5. No canceling, sorry. 6 times 2 is 12. 5 times 1 is 5. Since we don't like to use improper fractions, 5 goes into 12 2 times, with a remainder of 2. 2 what? 2/5. 2 and 2/5. 2 times 5 is 10, plus 2 is 12. Sister Mary Victor would be proud of us. Okay? How about, here's a little bit more complicated one. 3 3/4 divided by 1 2/3. Now pretty soon you'll be doing this all in one step, but for now I like to go a step at a time. And I'm going to leave the sign the same for the time being and get rid of these mixed numbers. 3 times 4 is 12, plus 3 is 15, so 15/4 divided by 1 times 3 is 3, plus 2 is 5, 5/3. All we did is change these mixed numbers to improper fractions. Now we're going to do our reciprocal. 15/4 times 3/5, and here we catch a nice break with the canceling. 5 goes into 5 1, 5 goes into 15 3 times. We end up with 3 times 3 is 9, 4 times 1 is 4, almost done. 4 goes into 9 twice, 2 times 4 is 8, plus 1 left over, 1/4. 2 times 4 is 8, plus 1 is 9, 9/4. I think we're good. Okay, so it started out looking like it was going to be a hard one, and thanks to canceling, really not so bad at all. All right, here comes another laundromat problem. I think you're going to see what I mean. 9 divided by 1/3. Now, I know we don't have any coins that are 1/3 of a dollar, but we're going to do it the same way. Each of these the numbers in this 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, has 3/3 in it. So 1 has 3/3 in it, 2 has 3 more thirds in it, and so forth. But to make it easy, 9, we'll change the sign to multiplication, and this will flip over to 3/1, or just 3, and it's going to be 27. If you want, I'll make that look like a fraction. 27/1, it's still 27. Okay? All right, for our last one has everything. And that is 3 7/8 divided by 5 1/6. Okay, 3 times 8 is 24, plus 7 is 31/8. Not too bad. Divided by 5 times 6 is 30, plus 1 is 31/6. Looks terrible, right? I don't want to multiply 31 times 31. So we'll switch it and see what happens. 31/8 times 6/31. Ooh, now it looks a lot different. 31 goes into 31 once. 31 goes into 1 once. That's it for the 31. And here we have a 2 goes into both of them. 2 goes into that 3 times. 2 goes into that 4 times. And we now have 3/4 for our answer. Okay? That has everything. All right? Once more, I have written a book, The Weber House, set in Maine. 2 13-year-old girls set out to solve a pirate's treasure. They think they are the hunters, but somebody is watching them. They are, in fact, the prey. And to solve the mystery, they even need some math. So if you'd like to check it out, I hope you enjoy it. Thanks.